Okay, problem number 29. It's a log equation. So I'm going to use the rules of logs to simplify. So the first step would be, let's write this down, the natural log. It's going to be a product, x minus 1, x plus 2. And that equals the natural log of x. The arguments are going to be equal. So x minus 1, x plus 2 times x plus 2 is the same thing as x. I'm going to multiply it out. You get x squared, excuse me, plus 2 minus 1, which is plus x, and then minus 2, and that equals x. Quadratic, and I'm going to take x from both sides, and you get x squared. I'm going to also add 2 to both sides. So what do you get over here? This would give you x equals plus or minus the root of 2, right? Now, I want to know immediately about this. It can't be minus root 2 because I can't take the natural log of minus root 2 in the real number system. So the answer over here is x equals root 2, not plus or minus, just root 2. If you want to check it, you can. How do you check it? Plug it into the original. Let me go through that with you. Natural log, root 2 minus 1 plus the natural log root 2 plus 1. That equals the natural log of root 2. All right. What do you do here to check that? I mean, root 2 minus 1 is certainly a positive number. Root 2 plus 1 is a positive number, and root 2 is a positive number. So what do? Natural log. This is the product of their arguments. So it's going to be, root 2 times root 2 is 2. This is just the check part, by the way. Then you get, let's see, plus root 2. Whoops, I made a mistake, by the way. Let me get my eraser out, too. Copy error. Let me get that again for you. So natural log, root 2 minus 1 plus the natural log, root 2 plus 2. And what do you get over here? You get the natural log of root 2. Let's go through the arithmetic, the natural log. You multiply it out. You get root 2 times root 2 is 2. Then you get 2 root 2 minus root 2, which is plus root 2. And then you get minus 2. And that, of course, is the same thing as the natural log of the root of 2. The reason being these cancel off. So it's a good answer. Let's go to the next question. Next question is solve a rational inequality. And the way we're going to do that is get this thing compared to 0, it already is, into one term. Let's write that over here. The common denominator would be x plus 1. Then it's going to be minus 2 times x plus 1. Let's simplify. You get x plus 1 on the bottom. Gee, what do you get on top? You get x minus 2x, which is going to be minus x. Let me just check that. X minus 2x, yeah, minus x. 6 minus 2 is 4. Put my number line down. There's 2 numbers that go on the number line. Where the top becomes 0, which is at 4, and where the bottom becomes 0 at minus 1. This is where these things are changing their signs, by the way. 4 does satisfy the inequality, by the way, because 4 would make that equal to 0. So I'm going to shade that in. The next thing is take some test values. A good test value after 4 would be 5. If you plug it in, what do you get? On top you get negative, on bottom you get positive. So overall it's a negative. That's certainly not greater than 0, so I would not shade that in. Take a test value between minus 1 and 4, like 0. Plug it in top, you get positive. Positive on bottom. Positive divided by positive is a positive. That's certainly greater than 0, so I'm going to shade this in now. I'm going to go below minus 1. And what's a good number below minus 1? I don't know, minus 2 is a good choice. On top you get positive, on bottom you get negative, so overall it's negative. So what do I know? I know my answer now. In interval notation, it would be from minus 1, not including it, up to 4. If you want to use interval notation, that's a fine answer. If you want to write it as an inequality, it's x is greater than minus 1 and is less than or equal to 4. Either answer is fine, by the way. All right, number 31. Number 31 is determine the values of A, B, and C. My recommendation is to multiply both sides by the LCD. The LCD, I'll write this over here for you, is x cubed minus x, or you can write down x times x squared minus 1, or you could write down x plus 1. Whoops, let me get my eraser out again. You don't have to write this down, by the way. X plus 1, x minus 1. Well, multiply both sides by the LCD, you get x squared plus 7x minus 2. And my goal is to figure out what A, B, and C, the values of those are, all right? So what do you get now? You get A, and then you get x minus 1, x plus 1, plus B times x plus 1, plus C times x minus 1. The first number I would choose to make it easy for me is x equals 0. And what would you get? You get minus 2. And if I chose a 0, the B and C disappear. But then I'm left off with the A. And what am I left off with there? It looks like I'm going to be left off with minus A. All right, again, if x is 0, I get minus 1 times 1, which is minus 1. So I know what A is. A is going to be equal to the number 2 now. Put a box in that, because they did ask for the value of A. I know A is 2 now. Let's go on to do the B, and I'm going to say x equals 1 now. And what do you get there? Well, on the left side, you get 1 plus 7. That's 8. 8 minus 2 is 6. On the right side, if you chose 1, the A disappears and the C disappears, but then you're left off with B. And what are you going to get over there? Again, if it's 1, 1 plus 1 is 2. 2 times 1 is 2. You get 2B. What do you get over here? B would equal to the number 3. All right, let's do the next number. I mean, when I say next number, the next number for x would be minus 1 to choose. It's a simple one. What do you get there? Let's be careful. You get 1 minus 7, which is minus 6, and minus 6 minus 2 is minus 8. All right, let's be careful about this now. And certainly the first term, the A disappears, the B disappears. And the C, if I put the minus 1 over there, you'd get minus 2 times minus 1, which is 2, so 2C. What does this tell me? It tells me C is minus 4. All right, let's go to the next question. Next question is solve the system. Any method is fine, by the way. And I think you probably know by now that if I were doing this thing over here, I would probably use the reduced row echelon form. All right, so an augmented matrix, and I'll write this over here for you. That's going to be 1, 1, minus 1. 1, 1, minus 1, then I get a 4. And then I get minus 3. I get a 2. I get a minus 1. And I get a minus 6. I get 3, minus 3, and a 2. And then I get 5 over here. All right? So what I'm going to do is, some row operations. And I think the first thing I would do, let's take a look at it. I'd probably say row 2 plus row 3. Row 2 plus row 3. All right, write that down. So row 2 plus row 3. And I'm going to give that to row 3. All right, let me write this over here for you. And I think the addition should be, somewhat easy to do. And looking at it, if I did that, I'd get certainly 0. I would get minus 1. I would get 1. I produce a 0, by the way, which is good news for me. And then if I add, the minus 6 and 5, I'd get minus 1. All right, so that's the first thing I did, by the way. Now, you may wonder what the second thing I'm going to do. I'm going to try to get another 0, by the way. And let's take a look at it. I'm going to say row 3 plus row 1. I want to give it to row 1. I want to emphasize, though, what row 3 is. This is row 3. All right? So let's go back and see if we can do that. So I want to add row 3 and row 1. And what are you going to get there? You're going to get 1. And minus 1 and 1 is 0. Boy, that's convenient, isn't it? And let's see, 1 and minus 1 is 0. So you get 1, 0, 0. Let's be careful now. And minus 1 and 4 is 3. All right? So I did my 2 moves, and I got an answer for what x is now. I know x is the number 3. I know that much. But I don't know the other things yet. And so what I'm going to do is I'm going to do a third operation. And I'm going to say the third operation is R2 plus R3. And I'm going to give that to R2. All right? And again, I want to emphasize that, R3 is still that highlighted line over there. And let's see what we get over there. What would you get? You get minus 3. Let's see, you would get a 1. And then you'd get 0. So minus 3, 1, 0. And let's be careful about this. Minus 1 minus 6 is minus 7. All right, let me write this down now. I know x is going to be the number 3. I'm going to put a box in that indicating that's one answer. I got to get y now. I'm going to use second row to do that. And the second row says minus 3x, well, it's going to be minus 9, plus y is equal to minus 7. So I'm looking at that, and I think y, it doesn't look that bad, actually. Y is going to be equal to the number 2 now, because minus 9 plus 2 is going to be minus 7. All right, let's do the z now. And I'm going to do the third row to do that. What do you get? You get minus y, which is minus 2, plus z equals minus 1. All right, what do I do now? I would add 2 to both sides, and you would get z would be equal to 1. If you want, you can go back and check it, and it's fine to check it. You check it back in the original system of equations, by the way. But my claim is x equals 3, y equals 2, z equals 1. Fairly simple numbers. All right, let's do this one over here. And this one says given. You're given something. You're given a fourth degree polynomial, but you're also given 2 roots to that fourth degree polynomial, and they want you to factor it completely. So let's write this down. So f of x is equal to 2x4 plus 7x cubed minus 4x squared minus 27x minus 18. And you want me to factor it completely. That means into 4 linear factors. Well, I know 2 of the factors already. It would be x minus 2, and the reason for that 2 is a root, and the other one's going to be x plus 3. But I do not know the other 2 factors by looking at it. All right? So what I want to do is I want to do long division to do it. And I'm going to multiply out the x minus 2 times x plus 3, and you would get x squared. Let's see, 3 minus 2 is plus x. And minus 2 times minus 3 is minus 6. And we're going to divide that into the fourth degree polynomial. We'll get a quadratic that's hopefully factorable. So it's going to be 2x4 plus 7x cubed minus 4x squared minus 27x minus 18. Let me get my eraser because I think I went too far with that. And let me get my pen back. What are you going to do now? I'm going to say, looks like 2x squared. That's going to give me 2x4. And then what do you get? Let's see, 2x cubed, right? Minus 12x squared. I'm going to subtract now. And what are you going to get? You can get 5x cubed now. And let's do plus 8x squared. Now what's nice about this division, if I'm doing it correctly, I'll get a remainder of 0. And that's with the understanding that it's truthful roots that we've given you, which is 2 and minus 3. So you get minus 27, minus 18. What do you get over here? I'm going to say plus 5x now. You get 5x cubed. Let's see, 5x squared minus 30x. You're going to subtract again. Well, you're going to get 3x squared now. You get plus 3x, and you get minus 18. Now, what do you do now? You have to match it. So I'm going to say plus 3 now. And again, the hope is we're going to get a 0 remainder. Otherwise, we made a mistake somewhere. 3x squared plus 3x minus 18. And lo and hope, we do get a 0 remainder. What's left now? Factoring the 2x squared plus 5x plus 3. I'm going to make an assumption it's doable. So I'm going to say 2x and x. And then I'm looking at that 3, and I'm going to say 3 and 1. I'm going to check it, plus plus. That gives me 2x squared. I get 2x and 3x is 5x, and 3 times 1, of course, is 3. So it's the complete factorization of it. All right, we're done with that question. So the next one solve for x and y. Now, granted, in class we've been doing like graphing it by substitution, and I'm going to do it by substitution. I'm not going to graph it out, but if you were to graph it out, you have a parabola and a line. And, the possibilities there is intersect at 1 point, 2 points, or no points at all. Let's see what happens with the algebra. So I'll set the y equal to y. So that means 2x plus 2. That's what y is. And y is also x squared minus x minus 2. What do you do now? I'm going to say 0 product rule. It's going to be x squared minus 3x. And then, let's see, minus 4 then, right? Let me make sure I did that right. X squared, minus 1 minus 2 is minus 3, minus 2 minus 2. Oh, yeah, it looks good. Let's hope it factors nicely. I'm looking at this, and x. And I'm going to say it looks like a 4 and a 1, minus 4 plus 1. All right, what I'm going to do now is, I know what the x's are. The x is going to be minus 1, and the other one is going to be x equals 4. But they want you mean to solve for x and y, to solve for x, so I got to get the x and y, by the way. And they're going to be an ordered pair of numbers, by the way. What's the ordered pair going to be? Minus 1. I'm going to use this equation to figure out what y is, by the way. You can use either one. What do you get over there? Well, if it's minus 1, I get minus 2 plus 2, which is 0. That's one solution. The other solution is going to be 4. So we plug the 4 in, and again, I'm using that second equation. 2 times 4 is 8. 8 plus 2 is 10. If you want, you can check it. How do you check it? Check it, make sure it satisfies both of those equations. All right, number 35, they say rewrite f of x as a single fraction and then perform the long division. Well, let me go up here. I'm going to actually do the arithmetic up here. I'll write this one down in a moment. X minus 1. This would be x squared minus 2 times x minus 1. What do you get over there? X minus 1. Let's see, you get x squared. You're going to be careful here, right? So you get minus 2x. And then you get, minus 2 plus 2, which is 0. So I wrote it as a single fraction. Let's write that down. F of x is going to be x squared minus 2x over x minus 1. This is done. I write it as a single fraction. But they also said do a long division. Let's do that. And I'll write this over here. So x minus 1, I'm going to divide that into x squared minus 2x. I'm just going to put a 0 here. Not that you have to, but I'll put it there. What do you do here? Well, what times x would be x squared? That would just be an x. What do you get there? X squared minus x. What do you get now? You would get minus x plus 0. What do you do now? Well, what times, x would give you minus x, that's minus 1. So what do you get there? You get minus x plus 1. You're going to subtract to get minus 1. So I'm ready to write this down after doing the long division as x minus 1. And it's going to be plus the remainder. Well, the remainder is minus 1, so I'm going to say minus 1 over x minus 1. And we're done with this. They've asked for both. We've done both. All right? We've done the long division, and we've done the single rational expression, by the way. What's the slant asymptote? Well, the slant asymptote is going to be y equals x minus 1. We're pulling that right from the above answer, by the way. Right? You can look at the graph that they've given you, and that does appear to be the case, by the way. Let's go to the next question. Next question is a multiplication problem. And, matrix of multiplication, I always say it's tedious to do, but the bottom line is it's not that tedious. It can be done. Before I do anything, I want to point out the size of this one over here is a 3 by 2. That's 3 rows and 2 columns, and this is a 2 by 2. These dimensions match, and I know my outcome is going to be a 3 by 2. So it's important I know that. Let me get my eraser out, that I can actually do the multiplication, by the way. And I'll write down some scratch work for you. But the bottom line is I'm going to have a matrix on this side over here, and that matrix is going to have 3 rows and 2 columns. Right, so, I in class I've always been circling things for you, at least initially. And they're going to be pairwise. What are you going to get? 1 minus 12, which is minus 11. That's my first entry, by the way, row 1, column 1. Now, the next one's going to be, 1 times minus 3, which is minus 3, minus 6 times 0 is 0. So I just get a minus 3. All right, what's the next one going to be? It's going to be row 2, column 1. 5 minus 8. 5 minus 8 is minus 3. And then I'm going to get minus 15 and 0, so it's just minus 15. The 0 makes it actually easier for me to do the arithmetic, by the way. Let's do the next one. So, minus 3 and then a 4. That's going to be 1. And then you can get 9 and 0, which is just 9. I'll put a box in this over here. Again, very little work. There's 6 entries over there. Minus 11, minus 3, that's the first row. Minus 3, minus 15 is the second row, and 1, 9 is the third row. All right, this is an exponential equation. I make a substitution over here because it looks quadratic in form, that u is equal to e to the t. Whoops. I was going to put e to the x down, but it's not e to the x, it's e to the t. I'll rewrite this as, it's a multiple choice, by the way, 2u squared plus u. I'm going to subtract 1 from both sides, and I'm going to try to factor it. 2u, u, 0, 1, 1, plus, minus. So u could be 1/2, or the u could be minus 1. I hope you realize that u can't be minus 1, because in a real number system, the t is going to be a positive number. So this is out of the question. So I got to figure this out. What do I got? I got 1/2 equals e to the t. I'll rewrite this as a log. So t would equal the natural log of 1 over 2. I don't see that answer being listed, by the way. This same thing is natural log of 2 to the minus 1, t. Pull the minus 1 down, you get minus the natural log of 2 would be equal to t. Is that answer being listed for me? It is. It's answer C. All right, 38 wants the difference quotient. And they're giving me what the difference quotient is, and they want me to actually do that. All right, so let's write this down. So it's going to be equal. It's going to be, let's see, x plus h squared minus x plus h plus 1 minus f of x, x squared minus x plus 1 all over h. I need to expand this out and simplify. What are you going to get? It doesn't look too bad. X squared plus 2xh plus h squared minus x minus h plus 1 minus x squared plus x, let's see, minus 1, and that's over h. Let's keep moving. As I'm doing this, I'm going to point out to you that some things really they just disappear real quick, by the way. So, for example, x squared minus x squared, they're gone. The x minus x, that's gone. The 1's gone. What are you left off with? Let's write this down. You're left off with 2xh plus h squared minus h over h. And the fact that h isn't 0 allows me to divide this through. And what are you going to get over here? You can get 2x plus h minus 1. And that's the final answer, by the way. And we're done. Thank you so much.